Welcome back to this video series of C++ programming. This is the lecture 26 of this video series, and today we are going to discuss about virtual functions in C++ programming. It is one of the very important topic and frequently talked topic in C++ programming. So let's get started. First, let's understand why do we need virtual functions in C++. To understand, we'll go back in the first lecture of inheritance where we took an example of a washing machine. So with the same example, we'll understand why virtual functions are required. So when you talk about a washing machine, there are two kinds of washing machines. First one is automatic and second is a semi-automatic. The function of washing machine is same, that is it has to wash the clothes. However, the semi-automatic machine achieved this purpose in some different way, and the automatic machine achieved this purpose in some different way. If you want to implement those washing machine a class in your C++ programming, then you can create a one function and you can call that as a wash cloths. For example, you have created one function that will internally execute the functionality related to the washing cloths, and we call that as a wash cloth. So now with the using the virtual functions or virtual keyword or virtual nature of a C++ programming, we can give the same name for both the functions. So the function will be defined in the automatic machine class as well as semi-automatic machine class. However, internally both these functions will execute the different functionality. However, the naming wise or the declaration wise, both the functions will have a same name. Not only name, it will have a same type, it will have a same number of arguments, and arguments type will be the same. So this is how this virtual function are useful in the C++ programming. So combining together with the inheritance and a virtual function, runtime polymorphism can be achieved in the C++ programming. So we talked about polymorphism in the previous topic. So there are two kinds of polymorphism. One is a compile time and second is a runtime polymorphism. So compile time polymorphism is achieved using the function overloading and operator overloading, and runtime polymorphism is achieved using the virtual functions and inheritance. So basically, the runtime polymorphism is uh, is applied to the events that's executed during the runtime of program, while the compile time polymorphism applies for the events those runs or those executors during the compilation time. The second point, virtual function is a member function that is declared within a base class using the virtual keyword. So virtual is a standard C++ keyword, and it is redefined by a derived class. That means the virtual function is typically declared within a base class using this virtual keyword, and the same function is redefined by the derived class, so as we talked before. The third important point, virtual function implements one interface multiple methods philosophy that underlies polymorphism. So one interface multiple methods means, again talking about the same example of function overloading, where function overloading is achieved by using the same name of function, but internally the functions will execute the different role. So there are multiple methods or there are multiple functions. However, there is only one interface. That means the functions, even though they have multiple functionality or different functionality, the name of function is the same. So this is how the one interface multiple methods works. The same applies for the operator overloading as well as the runtime polymorphism and the virtual functions. And the last point, when accessed normally, virtual functions behave just like any other type of class member function. However, what makes virtual function important and capable of supporting runtime polymorphism is how they behave when accessed via a pointer. When you use the pointers and the virtual functions, then it takes the actual advantage of this runtime polymorphism using the virtual functions. We'll talk about this point when we see an example. But first, let's understand these 3 points with the help of examples. So we'll create two classes. We'll call this as the base class, and we'll create another class. We'll call this as derived class. Now this derived class is derived from this base class, and access is a public. Now inside this base class, we'll create some public member function. We'll create one function. We'll call this as a v function. same function we'll create in the this derived class, and here we'll print as a derived function. However, to make this as a virtual function, you have to specify the virtual keyword here. And when you specify this keyword, then this v function will become a virtual function. So when you use this same function, virtual function, in the derived classes, you don't have to specify virtual keyword here. However, even if you specify this virtual keyword, this compiler will treat as a valid keyword or valid statement, so it won't give error. But however, simply it is not required, so you can simply however, it is not required, so you don't have to use that virtual keyword again when you redefine this virtual function. And inside this main function, we'll create a object of the, let's say first we'll create the object of a derived class. Similarly, we'll create an object of the base class. As we talked, the virtual function can be accessed similar to another normal functions using these objects. However, they plays an important role when we use the pointers and when we try to access them through the pointers. So first we'll understand how we can access this virtual functions with this object. So if I use this b object, and then I can access this virtual function. Now this function belongs to a base class. Similarly, using this d object, I can access the same virtual function which belongs to a this derived class. Now let's compile the program and let's run it. So you can see it is outputting first the base v function and another is the second string as a derived v function. So this access is similar to any other normal function. Now let's remove this definition of this virtual function or uh, another redeclaration of this virtual function from the derived class. And now let's run this program again. Here now we have removed this definition, however, still we are using this derived d object. We are calling this virtual function. Now let's compile the program and let's see what does it outputs. First thing very important to note is that the program has successfully compiled. And now it is printing the output as both the string as base virtual function. So now if you want to relate whatever we saw in the presentation, we can see here this when you don't specify this virtual function, or we don't redefine this virtual function again in the derived class, it will take the definition of the virtual function from the base class. So it is not required to redefine this virtual function again. The same function which is present in the base class can be used when you are calling this through a derived class object. However, the function or typical use of virtual function is to execute the specific functionality from these two classes. So this virtual function is typically used to perform the separate functionality, and again this function will be performing the different functionality. So it is good to have both the functions present within both the classes. Now let's understand how we can achieve the runtime polymorphism using this virtual functions and the pointers. So for that purpose, here we'll create a pointer of a base class and we'll create an object of the derived class. Now this will point this b class or the object of or pointer of this base class b to a object of the derived class. And now this pointer and this arrow operator, we can access the virtual function. Now can you think, when you execute this functionality, what would be the output? So whether it will output this statement or this statement. So here what we have done is we have created the pointer of a base class, and to that we have assigned the address of the derived class object. So we are pointing to an object of the derived class. and then using that base class pointer we're calling the virtual functions, which is defined in both this base classes and the derived classes. So in this scenario, first let's see what does it outputs. And it is now outputting as a derived virtual function. So that means when you call this function using the base pointer, it actually called the virtual function present in the derived class and not the virtual function present in the base class. So this is exactly how the runtime polymorphism is achieved. So basically, in this case, the call to this virtual function is determined during the runtime and not during the compilation time. And it is done based on this assignment. So here, when you the assigning any other address of any other object to this pointer, which function of this, which version of this virtual function will be called is determined during the runtime based on this object type of this object. If you would have assigned the suppose you create a base class object here, if you would assign the address of b1, then it would have called the function virtual function from the base class and not from the derived class. So basically this is how the runtime polymorphism is achieved, and this is done during the runtime, that is when you are assigning this address to this pointer. So I hope now you have understood how this runtime polymorphism is achieved. Now let's go back and understand more about the virtual functions. So first one, although you can call the virtual functions in the normal manner by using the object name and dot operator, but it simply does not take an advantage of the virtual nature of functions as we talked. So it is simply like calling any other normal function using the dot operator and that object. However, the redefinition of a virtual function by derived class appears similar to a function overloading. However, this is not the case, and the term overloading is not applied to a virtual function redefinition. The term overriding is used instead. That means when you create a virtual or you redefine the virtual function, it is not called as overloading. It is called as overriding instead. Because now, what is the difference between overloading and overriding? In case of function overloading, the function overloading is determined based on the arguments. So the function overloading differs in case of the number of arguments and the types of those arguments. So in these two functions, if the number of arguments are different and the number of arguments or the types of arguments are different, then they will act as a overloaded function. However, in case of function overriding or the virtual functions, both these functions will have exactly the same declaration. So the type will also be same, as well as the arguments and the number of arguments or the type of arguments will be same. So it's like exactly the same definition or declaration of the same function. So this is how this overloading and overriding differs, and the term overriding is used in case of virtual functions. The third point, virtual function must be a non-static member of the class of which they are part. They cannot be a friend functions. So they must be a non-static member. So you cannot specify the static members to those virtual functions. Also, you cannot specify them as a uh, friend functions. Constructor function cannot be virtual, but destructor function can be a virtual. So we'll talk about this virtual destructor in this video. And finally, when a virtual function is inherited, its virtual nature is also inherited. This means that when a derived class that is inherit a virtual function is itself used as a base class for another derived class, the virtual function can still be overridden. So no matters so how many times a virtual function is inherited, it will remain as a virtual function. So to understand it, suppose you have created a another class here, call this as a derived one, and We are deriving this class from this class called as a derived. Now in this case, this v function is a virtual, and when you are using the multiple inheritance, this v function is again became a virtual. So its virtual nature of this v function remains in case of a multiple inheritance. So if in the same manner, if you are creating the multiple classes and derive them that from the previous derived classes, virtual nature of this function will remain same. When a function is declared as virtual by the base class, it may be overridden by the derived class. However, the function does not have to be overridden. When a derived class fails to override a virtual function, then when an object of the derived class accesses that function, the function defined by the base class is used. So this we talked when we saw an example. That means you don't have to override that virtual function in the derived classes. If you don't override those functions, the virtual function once present in a base class will be called when you try to access that function through the base object or base class or the object of the derived class. The second point, because inheritance is hierarchical in C++, it makes sense that the virtual functions are also hierarchical. This means that a derived class fails to override a virtual function, the first redefinition found in the reverse order of derivation is used. So let's understand this point. In this case, suppose now we'll comment out this functionality, and here we'll create a object of the derived one class. And now we'll assign this uh, pointer with this derived class object, so which is of the derived one class. Now when you execute this functionality virtual function, can you tell which function will be executed? So whether it will print this statement from the base class or this statement from the derived class. So now let's compile the program and run. And now it is outputting the string as a derived virtual function. So why derived virtual function? It's because, as we saw in that point, when you derive this class derived one from this derived class, and if you don't use this don't override this virtual function, it will take the virtual function, the definition of virtual function, from its previously derived class and not from the base class. So this is how the this virtual function is used in case of a multiple inheritance, uh, or you derive the multiple object or multiple classes from the one classes. You can also call the virtual function through a base class references. The polymorphism nature of a virtual function is available when called through a base class reference. A reference is an implicit pointer. The base class reference can be used to refer to an object of the base class or any object derived from that base class. When a virtual function is called through a base class reference, the version of a function executed is determined by the object being referred to at that time of the call. So I think this is a self-explanatory. How we can use the references for calling these virtual functions. And finally, we'll talk about the this constructor and destructor. We'll talk more about the virtual destructor. So constructor will be called similar to how we create a how we use them with the normal classes. So when you suppose now you have say, let's assume now we have using this we are creating this given object from the derived one class. Here we create a constructors. Similarly, we'll create a constructor in in this derived class as well as in this base class. Now let's run this program and let's see what does it outputs. So it is outputting the three strings. First is a base constructor, derived constructor, and the last one is a derived one constructor. The reason is when you call this derived object, when you create this object, as we know, since we are using this inheritance mechanism here. So first it will call the constructor of the base class, and that's why it will first print this statement. Then followed with it will call the constructor of the derived class and will print this statement. And finally it will execute this derived one constructor function, and hence it will output this statement at the last. So how this is constructor works when in case of a this multiple I mean in case of derived classes. I'll talk about this virtual destructor. So how to create a destructor is you have to understand this virtual destructor, we first create a pointer of a base class and we'll allocate a memory of this class with the help of this derived class. And here we'll delete this object B. And now let's run this program to see what does it outputs. So these two statements are from the when this D1 or D object of the derived class is created. So it's called base constructor and derived constructor. And when you delete the object, it called this function, destructor function from the base class. So that's why it is printing output as a base destructor. However, if you see, it did not call the function, the destructor function from the derived class. So what is the problem here? When you are deleting this object, it is deleting the object related to the base class and not from the derived class. So this often creates a problem of the memory leaks. So here we have created the pointer this p, which is allocated a memory which is of the type of this derived class. And when you are freeing this object, since this object is of a base type, it is only calling this constructor destructor function from the base class and not from the derived class. If you want to free any particular memory related to the base class, then that is okay. You can delete it from this base destructor, but it did not call the destructor for the derived. So if you want to execute any particular functionality from the derived classes, a derived destructor, then that functionality won't be executed. So that is the disadvantage of uh, using this destructor function uh, in case of the inheritance. So how to avoid this problem? So to avoid that, you have to specify this virtual keyword when you are creating this a base destructor. So even if you are not doing anything, it is a good practice to specify this virtual keyword with the destructors, and those non-destructor will become a virtual destructor. This practice will help in programming when you don't want any sudden surprises. For example, now you want to execute some functionality from this derived destructor. However, because of this not specifying the virtual, the destructor is not called and it did not execute that functionality. So this issue is hard to determine when you're writing the program, and making a simple mistake that is not specifying this virtual keyword here. The destructor will go this issue unrecognized while writing the program. However, when you are trying to run the program that time, you find it uh, it's not working or not working as expected. So it's better to specify the virtual keyword as soon as you create a destructor in case of the multiple derived classes or in case of inheritance. Now let's compile this program again and let's run it to see what does it outputs. So now it called this basic destructor and the derived destructor string. So now it derived, I mean it called the destructor for both the derived as well as base classes. And the order, if you have noticed, it will first call this destructor from the class, uh, derived class, and then it will call the destructor from this base class. So their order of derivation is different or reverse in case of as compared to their constructor execution. So I think we covered almost all topics related to this virtual functions in this video. So thanks for watching this video and stay tuned for the upcoming videos.